Thank you for joining this lesson. We're going to discuss the equation of a straight line. Number 20. L1 is a straight line which passes through points -2, 5, 5, 16, and -4h. Find part 1, the equation of L1 in the form y equals to mx plus c. Remember to subscribe to this channel and to also share the link with friends. So what we're going to have in this case is first of all the gradient of line 1. So allow me call it m1, gradient for line 1. Change in y out of change in x. We can use the definite coordinates, the first one and the second one. So 16 minus 5 is the change in y, divide by 5 minus -2. So this means the gradient is going to be 11 out of 7, because this becomes a plus. So this is the gradient for line 1. Now with gradient, we can express the equation with his. Gradient of a line is usually given by change in y. So we let another point xy, so that we may say change in y out of change in x, y minus 5 divided by x minus -2, making it a plus 2. Yes. At this point, I can cross multiply to have 7y minus 35 equals to 11x plus 22. When 11 multiplies everything here, when 7 multiplies everything here, 7y equals to 11x plus 22 plus 35 becomes 57. So that now to remain with y, we can divide through by 7 and have 11 out of 7x plus 57 out of 7. So this is the equation in the desired format. Number 2, find the value of h. So for us to get the value of h, we can just use the gradient. Because the gradient is known, we can say using any points, as long as they are on the straight line, they would give us the same gradient. So 11 out of 7, the gradient, can still be obtained when we use h minus 5 divided by -4 minus -2, which makes it a plus 2. Yeah, so now we can obtain, when we cross multiply, we will have a 7h minus 35. This is equivalent to -44 plus 22. This could have been combined even at an earlier stage to have it as -2, so that this becomes now -22. Yeah, when you add. So we're going to have 7h equals to, this is 35 and there is a -22 at this point. So -22, when we add 35, we are getting 13. We're getting 13. I hope I'm right there. Yeah, we're getting 13. So that means now a value of h will be 13 out of 7, which is going to be 1.86 to 2 decimal places. So that is going to be the value of h. The next is part B. Equation of L2 is given here, and it intersects L1 at point A. Find the coordinates of A. The coordinates of A are, this is the coordinates of the point of intersection of L1 and L2, and we have the two equations. That means for us to find the point of intersection now of the two lines, we have to solve the two equations simultaneously. And the equation of L1 is here, equation of L1 is here, equation of L2 is here. So solving the two simultaneously, it becomes very simple, because we can express x from this point and say that from equation 2, x equals to 23 minus 3y. That means now equation 1 at this point becomes 7y equals to 11 instead of x, 23 minus 3y plus 57. Yes, now we can get the unknown y. This becomes 11 by 23, which is a 253 minus 11 by 3 becomes negative 33y plus 57. So now we can group like terms. So we will have this one, which is negative 33 being positive here. We'll have it as 40y. Then this is going to be 253 plus 57, giving us 310. So to remain with y, we have to divide by 40 through. This becomes 7 3/4, or rather 7.75. So the value of y is 7.75. Now we can get x. We can get x using the first expression here. X becomes 23 minus 3 and 7.75. Now that y is known. So we have 23 minus 3. And this becomes negative 1/4, or negative 0.25. So the coordinates of A, the point of intersection, now becomes negative 0.25, 7.75. So this is the coordinates of A, our point of intersection for the two lines. The next part C, point C, that is a T9, is on the line L2. It is given that the line L3 passes through C and parallel to L1. Find the equation of L3. Now, what we should know is that if the line is parallel to L1, then the gradient of line 3, the gradient of L3 is going to be, gradient of L3 will be equal to the gradient of L1. Let me get it. For two parallel lines, their gradient is the same. 11 out of 7. 11 out of 7. Now that it's parallel to L1. Again, it passes through C. It passes through point C. So something else we should know is that we can get the coordinates of C. That is the part T can be evaluated, because C is a point on L2. All right. And now for L2, we have the equation. That means we have the gradient. Therefore, we can say the gradient for line 2 is going to be, because the equation is 3y plus x equals to 23, we can have it as 3y equals to negative x plus 2, 3. So that y becomes negative 1 over 3x plus 23 out of 3. So the gradient is the coefficient of x. So gradient for line 2 is negative 1/3. Gradient for line 2 is negative 1/3. Yes. Now that it is negative 1/3 and gradient 2 or line 2 passes through point A and also through point C, then we can say the gradient is calculated by using point A. The change in y will be 7.75 minus the y in the other coordinate, 9. Then we divide by change in y, which is going to be change in x, negative 1/4 minus t. So this is going to be, when we have a 7.75, we subtract 9, we get a negative 1 1/4, or negative 5 out of 4. So we will have negative 1/3 equals to negative 5 over 4, that is 1 1/4, out of negative 1/4 minus t. So the only unknown is t. We can cross multiply. When we multiply this by 3, we're going to have negative 3.75 equals to, by negative 1, we get 1/4 plus t. To remain with t here, now we will subtract 1/4 at this point. So we'll have minus 1/4. This becomes negative 4. So the value of t is negative 4. The value of t is negative 4. That means the coordinates of C is negative 4, 9. Negative 4, 9. And remember, we are finding equation of L3. Equation of L3, we already have gradient as 11 out of 7. This will be expressed as y minus 9 out of x minus negative 4, making it positive. So this becomes 7y minus 63 equals to 11x plus 44. So 7y equals to 11x plus, we can have a 44 plus 63, giving us 107. Now that the format had not been specified, we can leave it at that point.